properties. That was almost disastrous. All right. There we go. It's not the first time that we've started without the right microphone on, but at least this time we recognized it.
Yeah, right at the beginning. So
yeah, so that's good. That's good. All right. Welcome to Data Science Club number 30. Today we're going to talk about just best practices for machine learning, and this comes from Google's rules for machine learning.
Yeah, and I mean, as all of you know, Google is really big on machine learning, so having some rules from them would be a really, really good idea to just go through them and see. They have about 47 machine learning rules or best practices. We are not going to go through all 47 of them. I believe it was 47, right?
43.
43, yeah. So we are just going to try to do the first 10, and we'll leave the rest up to you guys to go through them.
Yeah.
And they are very, very common sense kind of rules, but going through them once would be a good idea.
Yeah, at least once, and at least to have some formal verbiage behind why you might do something or why you might not do something.
Yeah.
And it might be something you haven't thought of before, but putting a rule to it's like, oh, well, that makes sense given that situation. And then even if you're not the person applying machine learning, if you're in a group where somebody else is applying it and they're going against one of these rules, then it's at least something to bring up. It might not, maybe you don't understand the full situation, or maybe there's really some insight that these rules can bring that will help us out. So it's definitely something to think about as in lots of different situations.
And I mean, some of these best practices would be since it's from Google, it would be in the context of some product deployment or something.
Yeah.
But even then, I think they have a general streak to these rules where you should be able to apply them to your machine learning models as well. Plus, everyone or a lot of you who would be going through that might want a job as a data scientist in a company where you will be deploying products, so it's good to have some basic idea of what these best practices are.
Yeah, well, and it's nice to notice that they compare it right at the beginning to a C++ style guide. So for somebody that's writing a lot of code, a style guide is basically like, hey, comment your blocks of code in this way. If you write a function, make sure you make a comment at the beginning of what the inputs and outputs are. Those sorts of things are involved in that. And so since Google is primarily a software company, they're providing this as kind of a style guide for machine learning. Yeah. Even though machine learning is more of like a statistical analytic toolbox, which is a little bit different, but it's nice to kind of see these concepts in that manner. So there's this video of Martin Zinkovich, which I'm not sure what his role is, but apparently he wrote this document, so it would be good for you guys to watch that. But we're going to skip on over it and just kind of talk about stuff. Let's see. Before we get into it, there's some terminology. So an instance is the thing about which you want to make a prediction. For example, the instance might be a web page that you want to classify as either about cats or not about cats. Mm-hmm. So an instance would be one particular data point. And so that would be like images or something like that. Label is an answer for a prediction cat. So in the above prediction task. Sorry, cats. Getting crazy up in here. So label is what we're trying to predict. Whether or not the web page is about cats, the about cats is going to be the label.
Still not as crazy as that movie that's about to come out on cats.
Yes. That one's all about cats. All right. Feature, so a property or an instance, a property of an instance used in predicting. So if a website has the word cat in it, then that would be a feature that would lead us to predict that it's about cats.
Yeah. Feature
Alright.
column, a set of related features that are going to help you in prediction. Example, an instance with its features and a label. So it's basically just giving you a particular row in a data set, right?
Yeah, with the label. So that's like labeled training data.
Yeah.
Is what it sounds like.
Model is basically what we have been doing, a statistical representation of a prediction task. So if you have used Keras, you'd be familiar with that model that you define and then train. That's the exact same.
Yeah, it's interesting here that this is a page about machine learning, and the Google, definition is just going ahead and calling the machine learning model a statistical representation.
Yeah,
that's interesting. I mean, I agree on some level, but it's interesting to note that.
Yeah, and I think they mention it somewhere. These terminologies are something that they use in Google internally, so it might not be exactly similar in some other institutions. So that is something that just keep in mind about that.
Yeah.
Because a lot of them can be really similar sounding. Instance, example.
Yeah.
That can be something that can be used interchangeably. So
it's nice to clearly define it. Metric, a number that you care about. So this would be like how many websites we accidentally classify as being not about cats when it's really about cats. Objective, a metric that your algorithm is trying to optimize. So maybe we can't actually quantify about cats or not about cats as well as we want, so we pick another metric to use as our objective that is something we can optimize with the numbers.
Pipeline is the entire infrastructure, so that would basically include like if you have gone through some of our earlier tutorials, like we import CSV files, how those CSV files are formed and all those things are part of the pipeline or part of the infrastructure around that model. And
click-through rate is totally
like I said, it's
search marketing thing, so I'm not really sure why that's in here, but maybe it's in here just because that's Google's main business.
And plus it's something that they are going to talk about in further down in the page, so these are terminologies that you need to know.
It's one of the examples they might be using.
But again, the thing that I was mentioning, that it is a Google document, so this click-through rate comes in because they are really worried about how many visitors are on their web pages.
They sell a lot of those click-through ads. All right. Do machine learning like the great engineer you are, not like the great machine learning expert you aren't. Oh, okay, so this is saying that if you are doing machine learning, there are really very few machine learning experts, but if you build a good, solid infrastructure to do your machine learning, then you're going to get better results, and you're going to be able to find better results, because there's not actually a good science of how you build the architectures and that kind of thing. So it is a lot of guess, test, and revise, and a lot of very, very practical like parameter tweaking. And if you're not systematic, then you can just kind of wander around thinking that you're making progress, but you're just kind of humanly overfitting the situation. So
I mean, if you are a great machine learning expert and you have bad data or
you have a bad pipeline, so nobody else can use your code, then it doesn't really matter.
So, but if you are an okay machine learning expert, you are just using Keras and all just the basic features, but if you have a very good pipeline around it, the way you get the data, what kind of features you get and all those things, then you might have a better prediction than the machine learning expert.
Let's see. Okay, so it looks like there's 4 different chunks. There's the first part is helping you understand whether it's the right time to build machine learning. The second is about deploying. Third is about launching and iterating while adding new features. The final about what to do when you reach a plateau. So let's see, we could either just go through the first 10 or we can make a random number generator and
just
do that.
I'm okay with either.
Just the first 10?
Yeah, first 10.
Let's do the first 10 and then read, if you guys read through the other ones and think we should talk about them or just want to come in and talk in office hours.
Yeah, definitely. I mean, if you go through that and you think that we should definitely cover the rest of them, let us know and we will cover them.
Yeah.
It's just that it's like a document, so we think that if you go through the first 10, it will give you an idea and you'll be able to go through the rest of them on your own. But
yeah. So rule number 1, don't be afraid to launch a product without machine learning. So this would be, similar. So like one of our students in the data science club this semester was really trying to figure out how and whether or not it would be appropriate to apply machine learning to his problem. But there's a lot of work to be done just cleaning up the data and building a model based on simple heuristics before getting to a place where he could really do machine learning. And
I mean, even the simple heuristics also helps you in actually getting data that you need for your machine learning model. It's basically like the example that they give over here is like if you are ranking apps in your app store, you can use the most basic heuristic, how many times that app has been downloaded, and that will give you some ranking for it.
Yeah.
But when you began your app store, you didn't have any other data other than how many times it's downloaded.
Yeah.
Use that data to make a machine learning model afterwards, but initially just begin with the basic heuristics.
Yeah, and that makes sense. And for a lot of research projects, even though you might be like submitting a grant or trying to do something really fancy and cool, if you don't have a basic model that's working first, then you're not going to know whether or not your machine learning is even working very well later.
Yeah, and it's basically like you might not get 100% of what you were thinking with the machine learning model, but with heuristic, you will be able to at least get to 60, 70% or 50% off.
And you'll understand why it works the way that it does.
Yeah.
And then
you need that data once from the heuristic that you have implemented. You need that data to actually build your machine learning model.
And it'll help you understand your data space better as well. So yeah, that makes sense. All right, so before you build your machine learning model, first design and implement metrics. So this is rule number 2. And so basically, if you can't measure anything about your system, then you can't build machine learning.
Yeah.
I think that's the gist of what's going on in this rule.
And I mean, it's also, at least the first point in it is like, it's easier to gain permissions when you are actually building things. When you're initially building things, like if there is a product that has been out in the market for some time, then it's much difficult to get it changed so that you get some measurable things.
Yeah, that's true. So like for us, we work with the research users using the scheduler, and it's, you can build into the system where we get to see all of the job scripts, but if you go and ask for that later after they've been working for a long time, then that's going to feel like an invasion of privacy. Whereas if you just go ahead and do that at the outset, then they might say like, oh, okay, this is just the way the system works.
Yeah. It's basically just that. And plus, the people who are designing that system will try to put those things already in place at the very beginning. So it's better to go get historical data now. Yeah, I mean, it's basically just saying that try to get as much measurable data as you can from your
Yeah, I
products.
mean, it's basically just setting yourself up for success
Yeah.
later. All right.
Which is a good point.
Yeah. I don't know why it keeps on doing that. That's a painful thing about that website. There we go. All right. Rule number 3, choose machine learning over a complex heuristic. So this is a good rule of thumb for when you need to convert back to machine learning. So the first one says, go ahead and ship it with a simple heuristic like an app ranking based on how many times it's been downloaded. But if your app ranking is how many times it's been downloaded and then deleted and then re-downloaded and then ranked and then how many minutes it's been used and all that kind of stuff, anytime you add a new feature, then it's going to break your heuristic.
Yeah.
And and it may only work for one type of app. So I remember building medical imaging pipelines where you're trying to segment the airways of a human from a lung scan. And so you build these, to build the model, you have to start with an assumption of where does the airway start and how many airways and what the structure is. And you kind of have to make an assumption. And there are textbooks that tell you what that structure is, but people in different parts of the world have different structures.
Yeah.
What's in the anatomical textbook is actually just a model. It's not the way that everybody's airways are. Everybody's airways are different. And so this makes absolute sense of it would actually just be easier to have a machine learning model.
Yeah, over a complex heuristic, and you don't, like they say, it's going to be easily maintainable machine learning model compared to a complex heuristic.
Mm-hmm.
And like William mentioned, if you add features in there, changing a complex heuristic is gets infinitely more difficult.
Yeah, and with that airway example, rather than having to say there may or may not be a branching point at this spot.
Yeah.
In addition to all the other rules you have, you just end up saying, okay, let me just put an example of that data in there.
Yeah.
All right. Why is it doing that? All right, so rule number 4, keep the first model simple to get the infrastructure right. Okay.
This is very related to, I think, the second rule that they had or something, where you get the infrastructure.
Yeah, the second rule was make your metrics first.
Okay. Whichever one. So it's basically just saying that keep the model simple. You can always start upgrading your model later on, but initially get the infrastructure right. Infrastructure can mean how you save the data, where you are getting all the data points from, determining what are the feature points that you want in your data set to predict something, get those things correct, where you eventually take the predictions and put it, that's another one of the infrastructure. So get all those things surrounding the model right.
Yeah.
Initially.
Yeah, and make sure you're checking your code into Git and those sorts of things. And you're absolutely right. This is related to that second one where you're making and implementing your metrics. Because if you go ahead and build the system so that it will be easier to update and you know where your inputs and outputs and things are, then it'll be easier to build complexity in later. But if it's complex initially, then it's going to be hard to know that it's doing what you want it to do.
I mean, that's always the case. I mean, we have been having it easy for right now that we have pre-built CSV files where we don't have to add features or anything to our data set. But that is one of the more important things. And I think a lot of data scientists do that portion as their day-to-day work a lot of gathering data sets and all this stuff, or cleaning up the data set.
Yeah, that makes sense. All right, so rule number 5, test the infrastructure independently from the machine learning. So a really good example of this is if you're trying to build like a UNet, which is an image segmentation network, it is because you start to deal with really complicated things where you're pulling in images separately from masks and you want to make sure that they're tied together. And then you may be doing augmentations to those where you're like flipping them and rotating and things like that. You want to make sure you have things built into your code to be able to check like, okay, am I reading the same image in with the same mask for that image? And are they doing the same transformations? And are they normalized between 0 and 1 appropriately so that the network can actually train on them? Because almost every person I've introduced those segmentation networks to comes back and says, my machine learning is not working. And what really isn't working is their infrastructure, their pre-processing.
Yeah. I mean, it's a good point about testing the infrastructure independently, and that gives a good example about UNet, and where you can actually see that rule in works.
Yeah, and similarly, I mean, if you're like putting a machine learning model on like an embedded processor or something like that.
Yeah.
I saw on the Kaggle newbies Slack channel this morning, somebody posted they made an app on their phone that would basically recolor your hair in live. So like it would bring in the image from your phone and then show you that image as if it was real time, but then you could select what color you wanted your hair to be. Just like a simple model. But there's lots of things just on the device that could be going wrong.
Yeah.
And so before you even worry about your model, you got to make sure that the model's getting the data that you want it to get.
Yes.
And then reading out the data that you want it to read out, and it may not have everything. You can post it, girl. It's right before Christmas, so I've got a baby with me. All right. So let's see. So number 6, be careful about dropped data when copying pipelines. Okay, so often we create a pipeline by copying an existing pipeline, and the old pipeline drops data that we need for the new pipeline. Okay, so for example, what's hot drops older posts because it's trying to rank the freshest posts.
This one is a good rule. I haven't seen that.
Oh, so this would be like if we're doing a Kaggle competition and we want to predict how. So let's say you have 2 different problems that you want to do with the same data set. So let's say you wanted to see what the price of a house should be based on the features of that house, square footage, age of the plumbing fixtures, the type of the plumbing fixtures that it has, that kind of stuff. And then you want to turn around and you want to estimate, or you want to predict the age of a house based on those same features. You might drop out things like the square footage of each and every bedroom in the sale price of a house. But it may actually help you predict how old the house is to know how small the bedrooms are.
Okay. So in the initial selection of features, you might drop out things.
Yeah, I think that's kind of roughly what it's talking about, because it's saying like just because you're pulling something in, it might be helpful for your overall model. Okay, come here, girl. It might be helpful for your overall model to have the previous machine learning model, but the infrastructure for that previous machine learning model may be deleting features that are interesting.
Yeah. I mean, this one is the most different one that I have seen.
Yeah.
For the drop pipeline, but
Yeah, it's again, it's a good thing to think about if you're having struggles trying to build a
definitely
model,
keep in mind about what features are getting dropped or what data points you are dropping, because that might influence how your model is performing.
Yeah. Yeah. All right, so rule number 7, turn heuristics into features or handle them externally. All right.
Usually the problem and to solve it.
Okay, so this is saying like, if you don't know where to start with your machine learning model and you have a previous heuristic model,
Yeah, you can.
that's the best place to start.
Yeah, that can be the data set that you are looking for. I mean,
Yeah.
basically, if you had a heuristic that was ranking the applications in an application store, then you can take that heuristic and make it one of the features in your data set from which you are going to be implementing that machine learning model. That basically gives you a good data point or a good feature point in every data set that you can try to predict upon.
Yeah. Yeah.
Preprocess using heuristic. Yeah.
And then, yeah, I mean, if you have a previous model that's based on those heuristics, then you'll have a feeling for what what your model should be doing with those heuristics.
Yeah, monitoring.
All right. So know the freshness requirements of your system.
Making alerts actionable and having a dashboard page.
Okay, interesting. So this is saying, okay, you can read that owl book, baby. So this is saying that once you have your model, how much does it suffer if the model is working on old data?
Yeah. It depends upon what's the age of your data.
And it probably depends on how much the system for collecting that data has been upgraded.
Yeah.
Like in our situation where we do like imaging stuff, if you have a new scanner, then you probably have to retrain your model.
Yeah, and I mean for something not related to machine learning or coding or anything like that.
Yeah.
It's something similar to how fast fashion works. It's basically like if you have dresses that were popular this week, then you'll have a good sales record. But if you are keeping clothes in your stores that were popular 3 weeks ago or 4 weeks ago, you might not have good sales. So this is something similar kind of similar to that.
Yeah, that makes sense. I mean, if you're still trying, like, I don't know. We kind of need Krish for that analogy.
Yes, he is the fashion.
He's gonna know what good fashion analogies are. But yeah, I could see like, I mean, if you still tried to sell Hanes clothes with Michael Jordan, like it's still probably gonna sell, but probably not as good as it would have sold when he was actually playing with the Bulls.
Yeah. I mean, it's this is basically just like that. I mean, even on Twitter, the trends change every day. So
yeah, I mean, like on the minute, sometimes they change. Yeah, so that makes sense. All right, detect problems before exporting the model.
Export the model to serving. If there is an issue with exporting, it's a user facing. Oh, yeah. This is basically just do all the testing which are not user facing. Do everything inside the organization first, all the testing, because once it becomes user facing, then that can become a bigger issue.
Yes, I mean, if you haven't checked, like we were checking those models for fairness with Patrick a few times ago, that if you haven't checked your model for fairness before it gets user facing, then suddenly you could end up in a situation where you have an Amazon model that's only hiring men and not hiring any women or something like that, and then it becomes a bigger issue. But it's not as big of a deal if you've gone ahead and done those checks before you export your model.
Yeah, watch for silent features. This is a problem that Just more machine learning systems than for other kind of system.
So number 10, watch for silent failures. And I think this is related to just the black box nature of using machine learning.
Yeah.
That sometimes it can start failing, but we won't know because of the way that the data looks. So like maybe most people that come into the emergency room are really just fine. And so maybe 90% of the folks that come in are healthy, and our model is telling us that everybody's healthy. And so then we're missing out on people that might have issues just because the machine learning model is broken.
It's basically just, and I think it's also talking about that if your data sets stop updating, that might cause your machine learning model to misbehave, especially if your machine learning model is something that is continuously learning from that data set.
Yeah.
And if one of the features just stops updating, then that just becomes stale. And just keep an eye out on all the features that are being captured.
Yeah. It's interesting. It's saying that the Google Play Store once had a table that was stale for 6 months.
Oh.
And refreshing the table gave a boost of 2% to the overall install rate. So basically, in addition to running your machine learning model in the real world, you want to continue to run some heuristic models, is what it sounds like.
Yeah, and it all goes down to, so from the first 10, if I had to find a common thing that came was the infrastructure, because even with the watch out for silent features, it seems like making sure that your infrastructure surrounding the model is correct, and you can test that out separately from your models.
Yeah.
And that is something that we have been talking about in almost all of our things anyway, that you have to keep all the surrounding things.
Yeah, doing all this machine learning and data science stuff, well, especially the more that we do it, seems more related to how do you set up the problem than it is on how do you, what architecture you choose for your machine learning. I mean, the architecture matters.
Yes.
But if you haven't made sure that your pictures of cats and dogs have a variety of backgrounds, then you may end up classifying dogs based on which ones are standing on the grass, and things like that. And so this infrastructure makes sense. This is much more like hardware and software developer-y than some of the other things that we've looked at, but it's a nice alternate way of looking at the problem space.
And 11, just because I'm seeing it, is basically give features column owners. That tells you that how expensive getting those columns are, that every column has their own owners of maintaining that. So
I mean, especially for something as big as Google, I guess that makes sense. That if you have this, how many downloads apps have a month
that's one person. You are the
you're the guy. You're the app download guy. And that they're going to have documentation so that they're kind of keeping an eye on it and making sure that the data's up to date and that kind of stuff. So, well, there you go. You got a bonus rule.
And go through all the other rules.
I find some sticker.
Stickers, baby.
And all the rules seems very generic, or it can be useful in your scenarios as well, whether you're working in an industry or not. So go through all of them and let us know how you feel about them. If there is one particular rule that you definitely think that we should talk about, send us a
Yeah.
comment or come to the office hours or send us an email, and we'll definitely talk about it.
Yeah. So with that, I think we probably will not be doing anything until after the new year. So happy holidays.
Yes.
Can
Happy
you say
holidays.
happy holidays.
Happy holidays.
There you go. So yeah.
Upstairs then.
All right. That's what we're doing now. All right. We'll see you guys later.
See